How many courses do you generally have every semester? Huh? Four. Just four. We used to have like six every semester. Four including electives. Any limit on number of electives you can take? In 2 years. Maximum six per semester.
Actually, there are some compulsory courses. Leaving that, you can take as many electives that are required to complete the course credit with 64 credits. Each course is 4 credits.
And you can take electives across any branch. Like, I don't know if you have humanities, so you can take humanities elective also. I mean, just an example.
On the number of humanities they can take.
So is it? So how do you select electives? Which ones where it is easy to score or easy to get good grades, or where the ROI is, I mean, ROI in the sense you learn it's more relevant to your interest, or it's a mix of.
Yeah.
Okay, we'll wait for a couple of minutes. And when does your mid-sem exam start?
So this time it's around starting week of March.
So I saw like 3rd to 8th, something like that, right? So for this course, what we'll do is I'll give you another assignment today in the second lecture, and then we'll have a mid-sem. You'll have a mid-sem exam also. So that will be maybe a 3-hour exam, an online exam. You can take it anytime based on your convenience, and it'll be questions which you can complete in 3 hours. Relatively straightforward than assignment. And now in the lecture, now we'll go through your submissions in the assignment. We'll go through some of the issues that I saw. Oh. Oops. Okay, so we'll start. So maybe we'll go through your assignment submissions one by one. I mean, some of the mistakes. So maybe you can start with your Ayush, right? Go to your assignment. So one issue I saw in your assignment, Ayush, is you have formulated. I hope all of you can see. Yeah, so you have formulated this way. I think is it correct? So basically, this is a screenshot from the assignment. Um, so yeah, just for I think to give a background for everyone. So this X. Oh, what is yeah? I mean, I don't remember. What is TI? TI are the teams.
That is the home team and I is the away team.
Okay. And D dash is the day, and S is slot and I think day night.
And reason.
Huh?
B is value.
B is value. Okay. So is there an issue? And mean gap is the minimum gap between two matches, and maximum gap, max gap is the max gap between two matches. And again, the reason for going through one of your all of your assignments one by one is to make sure that we don't repeat the same mistakes in the next assignment. Some of the mistakes could be careless mistakes, but if there is a conceptual mistake, you can rectify that. So is this correct?
So,
I mean, of course, you've written it, so if that's something that is because it is correct, you thought it is correct at least at that point of time.
so that in the previous constraint it was written that up to minimum gap there should be no matches.
Yes, yes.
And so we will start from the next day, right after D plus minimum gap we have covered, and then from the next day up to the max gap.
No, but doesn't that mean that, so let's say your mean gap is 2, mean is 2 and max is around 5. So you're saying from day 2 to day, so that means,
Day 3 to day 3.
so let's say you're talking about you have only 10 days in the tournament, so you're saying that from day, sorry, not 0, but you have day 1 to day 10. So you're saying that from day 4 to 4 to 6, there has to be only one match. There has to be at least one match.
Yes, sir.
But why not? Why it cannot be just? That means you are saying that within 3 days there has to be at least one match, but it is basically within 5 days it is one match, right? I mean, why are you adding that plus mean gap plus one is my question. Shouldn't it be just D in the lower subscript?
I guess it is not needed.
Hmm?
I think it's not needed.
Everyone else, what do you think? Is that correct? Yeah, okay, maybe the next thing, instead of me telling the answer, all of you can help to correct if it is wrong. Is that correct? So what it should be is, you should have only D in the in the lower summation and quality, and in the upper one is correct. And for mean gap, I think what you have written is correct. I don't remember now, but sorry, I think what I'm saying is wrong. So it should be D from D to D plus mean gap, right? It should be at least one match, and then from D to D plus max gap, there can be maximum one match, right? Sorry, it should be D to D plus mean gap, not D to D plus max gap. I just realized that.
Is that D2?
It should be between D plus mean gap plus 1 to D plus max gap, but it should be D to D plus mean. In the upper one is also wrong. It should be D
But
to
sir, from D to D plus mean gap, there should be no matches, right? Minimum, there should be minimum gap between two.
yeah, sorry. Then D to D plus mean gap plus 1.
From D to D2, from D to D plus mean gap plus 1, there should be.
At least one. So basically, yeah, sorry, D to D plus mean gap, it should be 0.
Yes, sir. So that was the previous constraint.
You have written that?
Yes, sir.
No, actually, there were so many. I mean, all of you have used different variables, and that is nothing wrong with that. So, Ayush. Yeah, but one good thing I saw is that all of your assignments are different. So that means no one has copied. So that was very. I mean, I think no one has copied. I don't know if ChatGPT can help to generate different solutions, similar, not same solutions, but similar looking assignments with the same solution. Okay, this one, right? So This one?
Third number, third.
Third.
Yes, sir, this
Ah, okay, okay. D2, D plus 1. But yeah, okay. Here, why shouldn't it be D2, D2, D plus min gap? I mean, why this plus 1?
So because on D we are playing a match, right? From next day we will count it.
Oh, okay, okay. Yeah, yeah, true. Okay. And the next, and that is minimum gap and maximum gap. Which one?
So this one only.
Okay, 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 okay. Oh, okay, okay. That way you meant. Okay, understood. Yeah. Hmm. Okay. Yeah. Yeah. Then it's fine. Okay. So I think apart from that, your general comments, what I observed is one is for this rain constraint. I mean rain. Yeah, rain constraint. Many of you have written that. Many of you have written constraints, and also all that is not required because and one of you has written that I don't remember who, but you have written that for we know the probability of rain before, but obviously you'll not know the probability of rain because if you know it rains, obviously you'll not keep a match on that day, right? So and for rain you don't really need to write any. So again, whatever we are writing, whatever was there in the assignment, the points, not necessarily that everything requires a constraint. We might be already handling that through some other constraint. So for rain, uh, the rain constraint is automatically taken care of because you have a minimum gap will be at least one. So if a match doesn't happen today due to rain, it will happen. I mean, if a match doesn't happen on the scheduled day, then it will happen on the scheduled day plus one because your mean gap is anyways, that will take care of that. So you don't need to write any separate constraint. So that is point one, and point two is for the event on an event day there'll be no match, those kind of things. All of you have written constraints. Again, that is not required. So what you can simply do is when you are creating that x, x variable, which x is indiced from the teams, the days, and the venue. There itself, you can avoid creating that variable when for that particular day and venue or that stadium and venue combination. So that itself will take care. So you don't need to write. I mean, what if you write a constraint, that is also fine. Nothing wrong with that. But a more elegant way of doing it is to avoid creating avoid creating the variable altogether. That is one point. And another point is, yeah, interesting. Many of you have considered that as a binary variable. That is, but I think that is more. That would be better. It would be better if that is a continuous variable. So the let's say India Pakistan match will be one, and some lesser interest match will be zero. But it can have some continuous values also like 0.7, 0.6, etc. etc. So then you will be getting a better solution. I mean, because this decision is not like whether it rains or not rains. So that's a binary decision. I mean, rains or not rains is not in your control. But let's say in a factory, whether you are operating a machine or not operating, so that is a binary decision. But whether a match is interesting or not, that cannot be a binary decision, right? Because it can be somewhere in the mix. It need not be white or black. It can be gray also, right? The second point is bigger capacity stadium should be looked at as. Yeah, again, this bigger capacity stadium also you can treat that as a continuous variable instead of treating that as a integer variable. Instead of treating that as a binary variable. Um, yeah, for rain we discussed. I do not. Yeah, this is fine. Um, yeah, and then the other point is since someone had written the smaller stadiums should get. And this is very true that actually we don't need to worry about the capacity of the stadium because since I mean if you are going for the home away concept, then the stadiums are anyways fixed, so you cannot really do anything about that. So you don't need to bother about this constraint.
Sir, but we can also say like in let's say
I mean again, if you have two stadiums, then it's a different thing. If one like as you are saying right last match that some team has two home stadiums, or then it's a different thing. But yeah, sorry, go ahead.
so that one.
Oh, okay. So I think Ayush, you're done. Sorry, your name is. Okay, so yeah, in parameters, you have defined many parameters as binary, integer, continuous. Nothing wrong with that, but again for parameters, we don't need to worry about whether it is binary or integer, continuous. That we need to worry about binary, integer, continuous only for variables, not for parameters. But again, nothing wrong with that. Yeah, rain probability. You have written something like you know yeah, rain probabilities are known in advance. So again, we don't know that because if we knew that, obviously we'll not schedule on that date. Yeah, then you have written this one. So this is the same what I was discussing earlier, that you don't need to create x equal to 0 for d is greater than less than start date and d greater than end date. Rather, you will create x variable only if d is within start date and end date. So yeah, nothing apart from that, it looked okay. Um, Okay, Jaren is not here, but so Jaren has written a lot of he has written a lot of so that's what I was telling yesterday. So he has put Slack variables everywhere. So this constraint that one team will play only one home match, one away match, those kind of things. Do we need Slack or surplus constraint? We don't need it. So yeah, we don't need to. So if something is completely hard, you cannot put you should not and you cannot put Slack variable. Um, so most of you have not used Slack surplus variables, even though it is required, but he has used Slack surplus even in where it is required and where it is not required also. So again, this one also he has put Slack variable coefficients. Who else is that? You have not submitted, right? Okay. And Mayank, right? Yeah. I'll go to your assignment then. Yeah, so this one I didn't. Okay, maybe before Mayank, I'll go to Utpal. So in your assignment, I did not. It was a bit complex. I was not understanding many of the things. So let's go through your assignment first, because there were a lot of. I mean, your assignment was most different from. Jaren's assignment was different from others in the fact that there was a lot of Slack variables, and your assignment was different because you had introduced a lot of concepts which I didn't understand. So first of all, how did you decide? And again, it's not wrong, but how did you decide these weights? Just wanted to check. Like I see very precise values like 0.008, etc. So let's discuss about this your weights first. Okay. Yeah, maybe you can go through these weights one by one so that we can get. I mean, all of us can get some. I'll also understand why you're. Most of it really comes from like viewership. Okay, first one I understand you have put the highest weight 10 because it is you want to make it. Okay. And then next highest I see is 3, so that no team has any score. Max difference like at during as a day some daily. What's the maximum difference between the number of matches played by you? So ideally tournament you won't want one team to play like more than around 60% matches in the first half and other team to just play like 10%. You have to keep that balance. So like that and also keeping it interesting. So that's got why it's to net allocation and cost allocation. Next highest and alpha 5 is also because which one? Which one? Alpha 5 is also yeah. We don't want to play like most of the home matches before, and or just the difference between the home and away matches should also be same because we don't want them to play a lot of home matches early on and a lot of the away matches. So that is the balance. Got it. Next, alpha 6 because night matches can be exhausting for players. So and maximum. Okay, before we go ahead, so what is the meaning of late night and what is the difference between night and late night? You meant night only, right? Night. Yeah, understand. But yeah, I was confused about that word late night. Asking what is late night. Okay. Okay. Because distance travel is not that much expensive from a revenue perspective. Okay. Total distance travel is like depending on the geography also. Yeah. Out of the also yeah, that will depend on the geography. Depending on the geography, like where a tournament is played, we might have to change our because usually
Because usually this is a lot of matches bring so much money, interesting matches, so the distance should be less of concern.
Again, it depends. Like in India, again, whether you fly from Bangalore to Chennai or Bangalore to Delhi, it does not make it maybe 1 hour difference, as you were saying in the earlier class. But if it's a bigger geography, like let's say Australia, west to east of the country is a big distance, there it might make some difference. And in the time zones, yeah, okay, fine. And you are left with Alpha 4.
Yeah, Alpha 4 max is minimum distance to make sure like the distance covered by the mean. Again, that also depends on the geography. Like, for a small
Okay, what is the difference Alpha 4 and I mean what is the difference between unfairly high travel and travel distance low? That is Alpha 2.
distance travel IJ is like the total distance that's traveled by all the teams.
Which one? The Alpha
That's
2.
again Alpha 2.
Oh.
That's the total distance that's covered by all the teams. Cumulative distance. All total distance. So that's the total.
Understood. Alpha
Max
4.
distance is like the maximum distance that was traveled by a team. And mean is the minimum distance that was traveled by a team.
No, sorry. So Alpha 4, Alpha 2 is the sum of the distances across all the matches.
Yes, across all the matches for all the teams. And Alpha 2 is the max distance, the maximum distance that was traveled by a team during the duration. And main distance is the minimum distance. So the difference between like, we also have to keep the travel distance between
No, what is minimum? Oh, minimum distance traveled by a team between two matches.
Yes, the different team travel most distance like if you go away from some matches. So the distance traveled by a team may not be the same. Some teams may not travel more than others. Some teams may not travel a little less depending on their geographic location.
But why do you need to worry about the minimum distance? You need to minimize the maximum distance.
Yes, the maximum distance we have to make sure like the distance there's not a big difference. One particular team travel like distance of same percentage so that's a big
No, that I understood. You're talking about Alpha 2, but in Alpha 4 you said minimum and maximum.
difference of maximum maximum distance that is traveled. That's a range. Minimizing the range of distance traveled by teams.
Oh, you mean okay? So one team, okay, minimizing the gap between the maximum distance traveled by a team and the maximum distance traveled by, let's say, different teams. Let's say we have only two teams. One team is traveling maximum distance of 2,000 kilometers between two matches. Another team is traveling maximum distance of 3,000. So you're minimizing that 3,000 minutes. Okay. I thought by minimum you mean I thought minimum distance. Okay, got it. Fine. And why it is 0.001? I mean 0.008. Why not let's say 0.005? That's your you thought.
The whole element is clear, and I don't think like you would almost we can be definitely much done about it.
So you think the total travel distance is lower priority than maximum distance? That means Alpha 2 you have put lesser weight than Alpha 1, Alpha 4.
Yeah. So balancing the distance is more important than total distance. Balance is more important.
Okay.
Also, like sportsmen are usually very toxic. One day favorite team has to travel more than others. Those things also happen.
What things?
Also, like usually sports, fans are fanatic. Their team has to travel a bit more demanding than their team might be on that. So, balance is important, especially in football.
Okay, fine. Yeah, I think I mean you are more or less a correct track. I think these weights look fine. So this is one way you can set the weights, but again, this is based on his understanding, and it looks pretty logical. So sometimes you need to discuss the business to understand what should be the relative, which weight is higher priority, which weight is lower priority. Now, what values you set, that is up to you. But yeah, it looks correct. So another question I had in your assignment is you have this variable. Okay, you have this n index, so I didn't understand that. Travel IJKN, yeah. So this one, yeah, this one, yeah.
LIG is like
This one. So guys are talking about this one. Yeah.
LIG.
No. Yeah, LIJN or travel IJKN, any of this.
LIG is like they place the home match. So LIJ it means that
No, I mean, do we need the n index at all? Is what I think.
that means like J plays a minute in the whole thing of so this is for like travel J, K, N was 1. If T travels from consonant in I, consonant
Yeah.
J with a net match.
Yeah, but okay, what is the meaning of team K travels from home stadium of team I? But I mean, K has to be either I or J, right? So why you need K?
So we can have like 2 consecutive away matches.
Oh, okay, okay,
So in
okay.
that
Understood.
I and J
Okay,
will
okay.
be inclusive. Maybe it could be also.
Okay, okay, got it, got it.
And if you can, so now I'm assuming like after playing their match in say some A, say same team C, for example, they play a match in say stadium A, and then the next match shouldn't be. They don't come from A to C and travel to B. They directly go from A to B. And there's no gap, right? Because directly go to the next stadium where the next match is shown. They don't come back to this particular. So that's a presumption that I have for simplicity.
And what is that capital N? I mean, I'm thinking if N is required or not.
And and it's like the end match. So N goes from two zero. N goes to say play the second match. Like L I J N where N denotes what's the match cricket. So if J plays their first match against I, it will be like L I J 1 equals to 1. So that denotes it. The match that they play against J comes from J. So like the first match or that match. So that's what it's keeping track of.
No, but why do you need that identity?
And so like I need to keep this order in this. Like, I need to know where they play there. So level IJ and like and I need to know like the difference. I keep track. Did they play their first match in this stadium? And that's it. So based on that I can keep the distance. And the distance. Travel. So I know like they play their NF match against this team. They play N plus 1 match against that team. And this is the distance. Then I know the distance. So that will so that means the travel distance. And if the travel distance, that distance was correct. So for the total distance.
I think there's a better way to do it, so we can discuss that. We'll discuss that later. Like in vehicle routing problems, also you have this kind of sequence, like from which node you go to which node, but you don't need the order. You don't need a separate index for the order. So we'll go through that. So N, I think we can scrap. And again, some formulations. I mean, it's not that it is wrong, but it will just generate more unnecessary variables. So it will increase the problem size. So we need to also see how to reduce the problem size. Okay. Oh, you have also a variable to count the number of matches played by team I as of DT. Again, these things I think we can. So all these variables, I think we have. We can scrap. Oh, if it is a linking variable, it is fine. I mean, linking variable in the sense. Okay, so let me ask you guys a question. So let's say you have a variable x. I don't know if I asked this already. So if you have a variable x, if you have two variables x and I, they are both integer, and you create another variable. I mean, let's say you have some constraint on x plus y greater than equal to something. Instead of that, you write. So this is one way to write. Let's say it's greater than 5, greater than equal to 5 is an example. Instead of that, you write z equal to x plus y, and then you write z greater than equal to 5. So z will be an integer variable or continuous variable. You can see what's written here. Right?
X and Y are
X and y are integer variables.
so that should also be
Integer variables. But if I write this z equal to x plus y, instead of writing this way, I'm creating another variable and then I write z greater than equal to 5. So does that, you can see right from there. So does that increase the problem size? Does that increase the solution time? Will that increase solution time?
no.
Why? Why I'm adding an extra integer variable?
Does it make a difference?
No, you tell me.
Population perspective is lower.
Hmm.
Doesn't change it.
Yeah. So it will not create a. It will for the solver. It will not have any impact. Yes. Again, so that's what I meant. So if you have if it is just if it is so I mean we call this as linking variables. So if these are linking variables, then it is fine. But if it is not, then we have to see how we can remove those. They are linking variables. Okay. Yeah. I mean sometimes we write these variables more for readability purpose. So if you have like 10 variables like this, you know, then in the code the line becomes very long. So even I just create another variable for readability purpose. So then it is fine. I mean, okay. The other point is. Okay, so your assignment is good. So now, Jaren, coming to your assignment. So your you have put a lot of slack variables. So for example, you have this,
Slack was like mistake.
yeah. So if some constraint is hard, like it's absolutely hard, like one team will play only one match, so there is no tolerance there. So then you don't need to put slack variable. But yeah, I think you have used more slack surplus variables. Other people, so other folks, they did not use where it is required, and you used where it is required, plus you used where it is not required. So you used in all the correct places, but you used in some of the places where it is not required. So but overall, apart from that, I think it is good. Your assignment was okay. Okay. So now I think Utpal is done. Yeah, so coming to Mayank. Yeah, so in your assignment, this one I didn't understand. No, actually, before I go here, no, I'm talking. Yeah, I remember there were certain things I didn't understand. There was all this XN, XC1, XC2. What are these?
So XIGD is like it's full market. Just match between I and J in the home stadium of I and B. IGD is the NIGD is indicator whether that match was a night match or a day match. NIGD, whether it was a night or day. This was one is night.
Hmm?
XIGD is like whether it was a match on the
Yeah.
day between I and J in the home stadium of I. That's what XIGD is. NIGD denotes the whether that match was night match or day match.
Okay.
NIGD.
Hmm.
And XNIGD is just the product of these two variables. Where NIGD is like either 0 or 1, depending on whether the.
So it's a binary variable. Okay. So you are. It is one if it is a night match, and it is.
NIGD.
Hmm.
NIGD is 1 because night match is 0.
Okay. Oh, no. 1 minute. NIJD is a parameter or a variable.
Variable.
Okay. So maybe you can.
I wrote the parameters first in the document below that.
Okay. And XC1, XC2.
Like there's an integer with constraints such that is equal to C1 GD integer variable which is equal to based on the constraints will also be equal to XIGD times count of JD.
Okay.
The constraints goes below and also say like what's this constraint as small constraint.
Okay. Okay. Got it. Oh, what are these match order constraints? 16. Yeah.
So like I will do like pointers for the persistence.
Okay. Okay.
To
Okay.
ensure these two conditions will C1 to be should go to that for the persistence.
And what will be the value of M? Hmm?
Small
No, M, capital M.
M is the bigger constant.
No, I got it. But what is what value you want to set?
Like what value should I use?
Yeah.
So count J is the number of that we will use so that total number is that we will
Okay.
it's not total. But that is some big constant like a million or so. That should keep it.
Why do you need that million constant? I mean, yeah. Why do you need?
Big M should be sufficiently large enough so that should be.
But right, but M cannot be greater than. I mean, the LHS cannot. Sorry, cannot be greater than the number of matches, right? No. I mean, M you should not put million because M should be the maximum value which X. I mean, the LHS can take. Sorry, LHS minus counts JD can take. That is XC1 minus count JD. So maybe XC1 cannot be more than the number of matches, right? Or is
Yes,
it?
it cannot be defined to be like IGD times count. Like XIGD is like binary.
Mhm.
XIGD is one, like this is one, then this will be equal to count GD.
No, that part I got. I'm asking about the value of big N. So XC1 is a what variable? Continuous? Yeah. So integer variable, right? I think, yeah.
Defined to be binary times.
Mhm. So you can put it as the maximum value which XC1 can take. So maybe, I don't know, the number of matches.
Yes, improvement is.
Yeah, that, so you don't need to multiply by a million. That is unnecessary.
So this question, like, is there like any penalty like things like a little more high than this in this case? In this case, like second to be number of matrix, or number of matrix plus one is like, sufficient in this case. If I were to put it like something much larger, like twice of number of matrix, is there any does it affect the solver in any way?
Yes, yes. If you put a higher value, then it will, it might have a impact on the performance. So the solver might be slow.
Like time taking plus one.
Yes, time taken by the solver. And I mean, if you multiply by 10, probably it will not have any impact. But if you multiply it by like a million, as you said, it might reduce the runtime. But again, the objective,
Is like setting it to be much larger than the formation.
it doesn't affect the formulation. Formulation is still, your constraint will still be valid, correct? But it will affect the runtime. It may affect the runtime. Okay, so I need, once I go home today, I need some time to read through your formulation. Yeah, okay. This one I understood. Okay, okay, fine. I think we'll stop at your formulation here. Otherwise, this is a lot to read. Okay. The next, coming to Mayank, your assignment. So one is you have this constraint. Yeah, this one I didn't understand. Let me open your formulation. This one, what is this one? Can you explain this O1 objective? Which one? You mean, oh, a capital IIJ. Okay, okay, yeah, yeah.
So it works as a weight
Mhm.
for the rest of the term.
Mhm.
And IIJ is the variable which is significant. So if IJ
Phi, that's phi, right? Yeah, phi is a variable.
has
The math is on a weekend, okay.
and LS is the trading capacity.
Okay.
So if IIJ is higher, it's important match. So we want it to schedule on a weekend. And it's the weekend on weekend.
No, 1 second. So first of all, the LS is the size of the stadium.
Yeah.
So why is it in the denominator? Because that means you are saying that smaller the stadium, bigger should be.
But it's negation, so it will count.
Oh, okay. Okay, but
Because 1 by LS will be between 0 and 1. So
okay, it's a bit messed up. So one in that, what you have in bracket, one and one minus one. Okay, then phi ij is a variable. So first of all, you are multiplying phi ij with x, right?
it will plug with that.
No, but that, so phi ij is a variable, right?
So the variable.
But then you're multiplying a variable with a variable, right? So that makes it non-linear. So that is the first thing. And the second thing is, okay, in the weight you have Ij, that's fine. And then you have phi ij minus. So phi ij is whether the match is played or, sorry, match is on a weekend or not. Yeah. And what is IJ? IJ are the teams.
I just think,
But then you should also have an index for the day, right? Because IJ there will be two matches, one home match, one away match.
so like you said, we get Pakistan match, so wherever we put it, that match.
Ah, that way you're saying. Got it. Yeah. Okay. No, but the main thing is but again, why are you adding this?
One.
Yeah, I mean, like 1 by LS will be a very small number, and then phi ij is a binary. And yeah, why are you adding 1?
So, so because 1 by LS is between 0 1, so
Okay.
can be negative. So 1
Hmm.
makes it positive.
I mean, it's a bit, all over the place. So I think phi ij. I mean, even if it okay, let's assume that you're okay with non-linear formulation. Even then, I think phi ij should then go outside the bracket. It should be multiplied, meaning phi ij should come here instead of iij. And iij is binary or continuous.
It's continuous. The importance
So then
of-
iij should come inside the bracket because you have put, in what you are multiplying with, so 1 and 1 minus ls, these are minus 1 by ls, these are parameters, and then phi ij is a variable. So the weight is a variable minus parameter, so it's a bit, confusing. And even if you're okay with nonlinear, and then phi ij should come outside, should be outside the bracket then. Okay. And then the second one, that is, second one, whatever, you multiplied x with x, right?
Yeah,
And then,
so I solved it because I
okay, yeah, okay, yeah. Right. Yeah, then second one is you have written this fifth time gap between matches. So this one you have written. So why is this, right? So what you are saying is if this is equal to 1 and if this is equal to 1 and d1 less than d2, then I will write this constraint. But you cannot write if this and this, right? Because you don't know what will be the value.
these are also constants. So
So these are, but let me if I'm wrong. So what you meant here is you want to write that if this is equal to 1
yeah.
and this is equal to 1 and d1 theoretically you will know, but you will not know this when you're solving the model, right? So you are making it, you will not know this. So you cannot write it in this way. You have to write it in what I told beginning that it will be greater than equal to 1. Yeah, I use it. So yeah, I think apart from that, it is okay. Who else? No one else. Is your name? Sure. So yeah. So for your assignment, many constraints I couldn't understand. Okay, so there's something I've written interesting. So one thing I liked is you have written this one that this concept I like, that interestingness. So there's for a match. Okay, but yeah, actually, interesting fact, whether a match is interesting or not, that depends on both the teams. It doesn't depend on one team. And then this ideal. Hmm? Okay, maybe I'll just go to your assignment. This line, yeah. So interesting, whether match is interesting or not, that depends on the which teams are playing, the pair of teams. So it doesn't depend on a particular team. Yeah, but this one I like, that ideal match distribution, total dates by number of matches for a team. Yeah, so we should try to stay, when you are doing that Slack surplus, we should try to stay close to that number. Okay, now coming to your constraints, I didn't. Yeah, maybe I see your constraints, but some constraints I understood, but because you haven't written a description, right? What is what? So I couldn't understand. So maybe can you resend with just a one-line description of in the same wherever I've written down this in the paper, you can just write down what that constraint does, a one-line sentence, and then I'll try to understand. But this one I didn't understand. What is this slack plus surplus minus g less than equal to 0? What does this do? Which objective? No, I mean, what is the which objective? Like, is it the zone time? Yeah, that is fine. But what is the business thing you're trying to address here? Yeah, I mean, maybe better you can just write a one-line description of what each objective does, and you can just resend it. So then we can discuss next time. Okay, so I'll skip this. Who else is left? I think we are done with everyone, right? Yeah, we're done with everyone. So okay, so then for people who are not there, so there were certain. Okay, this is fine. We'll not go through this. So someone had submitted this one. So I like this constraint. So when we say that a tournament has a start and end date, there is up and down is not here, right? So ideally there has to be a match. So if you do not put this constraint, what might, so let's say my tournament was over a span of 30 days, and it can allocate a match on second day and 29th day. It may skip the first and 30th day. So ideally you should have something, at least one match on first and 30th, because first is inauguration and 30th day will be the last. So this constraint is actually, at least for start date, it is important. I mean, even for the last, I think round robin is fine, but at least start date should have a match. So this constraint is very important. But even I not realize this constraint is there, should be there till I read this assignment. I think this is fine. This is. Yeah, I think apart from that we are good. So any questions around the assignment? So I hope some of you will take some feedback from this, and next assignment we can it will be a better submission. This submission is also okay, not bad, but yeah, I'll expect some improvement in the next submission. Okay, so then what we can do next is we can see how problem is actually written and solved. So I have opened this code. So all of you know Python, right? So this is one of the problems that I'm working on currently. So this is a fairly simple problem. So oh, okay. So so in our organization we use Express as the solver. So this is you'll be importing whatever data frame is required. Then you will be reading the data from here. I'm reading from Excel, but you can read from database or whatever data source you have. And then we import the solver license. We import the solver package. So in our organization we use FICO Express. So I'm using that. And this is what it says here is. If the license is not there, then I'll be getting a license. I'll be getting an error message. Else, I'll be displaying error. License is okay. License available. And also, I'll be defining some parameters here. After that, I'll be doing the the data processing. Here there is not much data processing, but so after that, I'll be defining my model here. So this xp.init. So here we are initializing the problem, and then we are defining the variables here. So if you look at these are all my variables up from here to here. So now let's go through one of them. So let's look at the first variable. It's C2 equal to TDF. So TDF means these are the indices of this variable, and var xp.var name equal to c2 underscore 012. So this is the name how you would want it. So this is optional. So this is how you would want it in the LP file. So the LP file will come to that later. So here instead of writing c2, you can write your own name also. Doesn't matter. And then var type is xp equal to integer. So that means this is an integer variable. Now, if you look at the other lines, we have integer, we have binary, we have all these are binary. Integer, we have these variables, and we have some continuous variables. So these are all continuous, and then we are writing this line for t in for d in range 1 to 6. All of you know about loops, right? For f in f, that means this variable will be defined on these sets. So the sets, so one way I can write is I can write for t in t, then the next line for d in range 1 to 6, the next line for f in f. Then I can write create the variable. Other way they can write in one line. So this variable will be created for this all these loops. So the number of variables that will be created is capital T into 6, rather into 5, and multiplied by f. So these will be the number of variables created. So in this case, it will be capital T into, after that, 6 or 5. So what I'm trying to find out is the number of, is the problem size I'll be having. So this means the size of the set T. And after that, it will be, for D in range 1 to 6, it will be 5 or 6. 5. And then into f. So this will be my this will be the number of variables, C2 variables I'll be having. Now let's say if I write a line here that if let's say small t and f have a certain belongs to a certain tuple. All of you know about tuples, right? So if small t and small f belongs to a certain tuple, only then I want to create. Then it will reduce further. So this is the maximum number of variables I can have. But if I add any if condition after that, it will reduce further. So that will be my eligibility matrix. So similarly, I'll be defining the other variables in this way. You can see all these variables. Then I need to add these variables to the problem. So whatever variable you define here, you define in the above lines, must be added in this add variable line. So if you define a variable here, and if you do not add it in this line, then you will get an error. And then again, there is again some data processing I'm doing. And then I'm writing the constraints one by one. So this is one constraint for D in range. Okay, maybe actually it's instead of that, I'll go to the problem that we were discussing yesterday. Just give me one sec. Yeah, so yesterday we were discussing about the inventory problem. So these are the variables that we have there. And then we discussed about the inventory balance constraint, for example, right? Yeah, so we are connecting the MOs and MIs using the lead time. So this is the constraint for that. So we'll be writing the loop. We'll be writing the different loops, and then for each time period, this is another loop, and then we'll be writing this line. So this is the optimization line. This is the constraint basically. So what we are saying here is that you can forget about the rework part, but basically MO2 equal to MI3, then time plus lead time. So this is essentially what we are doing yesterday, right? So this is the kind of constraint we will write. So that way you can write, in this way you can write the other constraints. So, and then this is the inventory balance constraint. So this way you can see that we are adding the different constraints. So this prop, wherever you see prop dot add constraint is the line of constraint you're adding. And so, and the objective is, okay, objective comes after this. So objective is here. So these are this is the objective function. So objective you can define either before constraints or after constraints. As you know, it doesn't matter. So this is objective. So then prop dot set objective this. So how do you tell whether we are minimizing? How do you tell the solver whether you want to minimize or maximize? By writing this line sense equal to xp dot minimize. If you want to oh, you can see, right? Oh, sorry, you should have told. You are able to see the constraints earlier, right? So the constraints are, you'll write the different loops. You'll write one loop, then the if condition, whatever loops you have, and then you will write the prop dot add constraint here, right? And then you will write that way. You'll write all the different constraints, and then the objective you'll write here. So based on different parameters, I might have different objectives, and then this line will set the objective. So sense equal to xp dot minimize. So here we are telling the model whether to minimize or maximize. So if it is maximize, instead of, you need to write xp dot maximize here. And then these are some solver parameters. So here we are asking the prop dot set control max time 150, meaning we are asking the solver to return whatever solution we get in 150 seconds, that is 2.5 minutes. And MIP, we'll again go through these parameters later on. MIP rel stop is, we are asking the solution, we're asking the solver to stop. So this 0.03 is in percentage, as we're asking the solver to stop once it is 3% away from the optimal solution. So once we reach the 97% optimal solution, we're asking the model to stop. Then here we are writing the writing the problem in the LP file. So this LP file will be stored in this location, and I can access it. Then prop.solve is the line where I'm asking the where I'm asking the solver to solve the problem. So this will solve the problem. And then here what I'm saying is, if prop.get prop status equal to 5 or 7. So this is this. So again, for express, what are the different problem status possible in optimization? We discussed this earlier in the third and fourth lecture. One is obviously you get an optimal solution. What are the other status? What are the other things possible? You can get infeasibility. Yeah, you can. Yeah, optimal solution is feasible, but it can be infeasible. All of you remember what is infeasible. Okay, and apart from that, you can get alternate optimal solution. You can get the alternate optimal solution. Actually, it is same as optimal, so it will not show anything. I mean, it has the same status as optimal solution. And another problem you might have is it might unbounded. Unbounded is, all of you remember. So that could be another problem status. So I think 5 is infeasible and 7 is unbounded. So what we are asking here is, if it is infeasible or unbounded, then prop.iis also, what is prop.iis, all will come to that later. And if it is feasible, if it is optimal, then we need to do some post processing. So these are different attributes you get from the model solution, that you get the best objective value. So best objective value is the objective function value that you get after solving the model. And best bound is what could be the best if you had solved it to complete optimality. And then this get solution will give you the solution of the different variables. So if you see there, I have all these get solutions here. So get solution is like, if you have X, Y, Z variables, this get solution will give you the value of each of those optimal value that the solver found for each of these variables. So once you get those values, you can convert it, you can put that in a data frame, and you can do whatever you want to do with that data. So all this is post processing. So this is again simple Python code. And then in case you want to write the result to a database, you can write it here. So this is how an optimization code looks like. So you have pre-processing at the beginning where you import all the required packages. You read data from database and you do all the pre-processing stuff. So this is all pre-processing, and after that you have the model code here. The model code starts from here, and you define the variables. Now, what are these? These are the sets. So these sets have already been defined earlier in pre-processing. So then here we define the variables on these sets, and then we define the constraints, the objective function, and then the solver parameters, the stopping criteria, and then we ask the model to solve the problem, and then we get the solution and we do the post processing. So this is how a Python code looks like. Unfortunately, I cannot run this model because my license is right now not operational. So next time I'll show you. But this is how a code looks like. Now, when you write this LP file here, prop.write, so this LP file gets written in my computer, in the computer on your local machine. So then you can diagnose, you can read the LP file to see if the LP file was created as per your expectations. So let me just open the LP file here. So this is how a typical LP file looks. You cannot see, right? So this is how a typical LP file looks like. You can see, right, from behind. So it will be either minimization or maximization, and you will have all these variables. So as you can see, these are the different, these are your variables, and the preceding numbers are the weights of the variables. So you can see there are so many variables in the objective function alone. And then from here, we start the constraints. So anyone can tell me what does R mean here? So R is row. So in optimization, the constraints are called rows and the variables are called columns. So R stands for row. So here I have not given any. So if you see my code, I have not given any name for my. So I have named the variables. So that you already saw. So the variables are named here. So name equal to this, but the constraints I have just written prop.add constraint this. So it will assign a default name. So it will assign, if you have 100 constraints, it will assign the names as R1, R2 up to R100. So that's how the variables, that's how the constraints get renamed. But if you want to, if you have some issues in finding, in a constraint, then it's better to give us this name to the constraint so that it is easier for you to troubleshoot. So in that case, you can give a name to the constraint and it will have the same indices as the variable. Now coming to this constraint, so you can see there's a left-hand side and there's an right-hand side. So the RHS contains only a parameter and the LHS consists of only variables. This way we have if I go to the end of the file, I have 1788 constraints. This is a very small problem. This is just maybe a 1 MB file size, but I have seen problems where the LP file itself runs into GBs. LP file is bigger than the size of a movie, entire movie. So this is one problem. So this is how the LP file will look like. And let's say if you rename the variable, if you rename the constraint, it will have the same indices as the the variable. Now, how it is, why reading this LP file is important, because sometimes what happens is you might have written something in the code. So whenever you have written a constraint, so let's say you have, we were going through the inventory problem yesterday. So you saw there were different kinds of constraints, like inventory balance, etc., etc. But suddenly you see that your inventory balance, you want to check if an inventory balance constraint is appearing in the API file. So you can open the API file and you can see if it is appearing or not. So it might be that you have coded it. There was some issue with the code, some mistake you made in the code. That's why it is not being written. So you can always look at the API file and see if it is there. Similarly, let's say a variable you are expecting to appear in 5 constraints, then you can pick up that variable. So let's say this is the variable. For example, you are expecting this variable to be there in 5 constraints. So you can just click on this one, right? And then you can find, so the count says 24 matches. So that it is there in 24 constraints. So that way you can verify if your variable is, if all your constraints are correct or not. What else? Yeah, and generally we read this file using using Notepad++ because of it is more readable in Notepad++, but you can use other softwares also. And yeah, yeah. Sometimes you okay if you have a constraint like this in the LP file. Let's say if you have a constraint like this, let's say R7. Is this correct? Will the model crash? I mean, will the solver crash? So there is no LHS basically. R7, no LHS. First of all, is it possible to get something like this? Less than equal to 10.
There is nothing on the LHS, it should assume easy.
But why will you get this kind of a constraint? Okay, I can think of this from a programming perspective, not from a model.
One variable minus same variable.
What you're saying is, let's say x minus y less than equal to 10 and x and y are equal values.
X minus X.
Oh, x minus x. That is also possible technically. I don't. I've not seen what happens if you write like this, but yeah, that is possible. But apart from this,
And then, sir, even if we consider this will result in 0 rather than something being blank.
it could be 0. Then it might be appearing as 0 also. I don't know what happens in that case. I'll check that. But yeah, it could be showing as 0 also, or it could be showing as blank also. I don't know what happens. But let's say this is not the case. And under what condition you can get this kind of a constraint in the LP file. So this will happen if in your code, when you're writing the loop, if you are creating the LHS, when you are creating the constraint, you might have some constraint, you might have some condition like if something, if condition something, then the LHS, let's say Z is your variable. You are creating the Z Z is your LHS, and LHS does not get created, right? So I mean, LHS doesn't create it because if condition is not satisfied, then you will get the constraint will still be written, but the LHS will not be written. So if you have this kind of a thing, it doesn't mean that you will get a wrong solution, or the solver will crash, but it is unnecessary then to write the constraint itself. Yeah, so as I said, LP files sometimes run into GBs. So in order to make and if you're diagnosing, if you're troubleshooting problems on a daily basis, it might be sometimes difficult to even to open a file which is 1 GB big. So in that case, it is probably better. How will you reduce the file size? Will you remove some of the constraints or variables? So let's say this file is, this file is actually 1 MB, but let's say this is 1 GB, and if you just open the file, it takes 2-3 minutes, and then to find it will be another big hassle. So how will you? But again, you need to read the LP file because you need to find some issues for which reading the LP file is important. Going through the variables, how will you reduce the file size?
We can reduce the variable names.
Okay.
Like if Slack capacity is given, you can write Slack cap.
Can you reduce some? Can you remove some of the? But I can remove some of the variables, right? Sorry, not variables. I can remove from the constraints itself or the variables, right?
We remove some constraints which were actually troublesome in code.
That is a good way. Obviously, you cannot remove constraints and variables, but yeah, you can shorten the variable names. Yes. So yeah, Slack capacity to Slack is one thing, and then if you have a big name, here you don't have any big variable names. Like let's say you are doing this for your factory and you have a product which has a 10-letter name, you can reduce it to 3 letters. Or the more elegant way to do that is in bigger projects, bigger in not organization, bigger projects, what they do is, okay, again, this is a programming thing. So if you have names if you have strings in your data, so strings will take more time. So generally, what they do is, let's say you are running an optimization model for a semiconductor company where you have 100 products and they have 100. You are running the model for that. So you will be converting that to numbers. So instead of 100 text, 100 strings, you will get 1, 2, 3, 4, 5, 6 up to 100. So then we do the optimization. I mean, your entire, not just optimization, everything is done on that 1 to 100. So even from a programming perspective, it is better, it is faster to read numbers than strings. So we generally convert strings into numbers in bigger problems.
That's where in LP file numbers will be.
Yes. Now you can ask, how will I know which product? So then you have to again see, you have to first convert the number to. Yeah, but when you are reading, even in the data from the database perspective, when you are for all the database operations, also it is better if you are using numbers instead of strings. If you have a lot of strings and
That's what I'm saying. The key would be the numbers and the
yes. Yes. So that is another way. You can replace the new string names with numeric numbers. Yeah, and then what happens sometimes when you are stuck on a problem, sometimes you might get different problems in your after you solve the problem which you are not able to diagnose yourself. So you might need to like in in other subjects you can upload in different forums where people will then try to help you out, or you can even share with the solver company. So you can share the LP file with the solver team, and they might be able to help, or forum to seek help. Then you need to encrypt the variable so that your variable names are changed from the product name to random characters like C1, C2. So here we have given that, you saw in the code that we have passed that syntax name equal to something, right? So if you don't do that, the solver will give some random names which you can use. So that I'm talking about this. So if you are not using this one, name equal to this or this, then the solver will give some default name, like it will give C1, C2, C3, C4. So those will be random names, but that you cannot use for your own troubleshooting because you don't know what that C1, C2, C3 is, which product or which time period that corresponds to. But if you want anyone to help you based on the solver file, based on the LP file, then you need to uh, create that in that fashion. Okay. What else? Okay. We'll go for another 5 minutes. Okay. Yeah. So, okay. This is left. Sorry. Another question that I had is, so let's go to this problem. Okay. Suppose this is a simpler problem. So let's say a factory has a factory has locations. Sorry, a company has factories at two locations, L1 and L2, and workers can move between location L1 and L2 based on the demand and supply. So let's say if you have more demand of work in L1, supply in the sense supply of workers. If you have more demand in L1 and more supply in L2, then you can move people from L2 to L1 and vice versa. So you want to create a variable which will indicate how many people are moving from L1 to L2 or L2 to L1. So obviously it will be only one. It will be only one direction. You cannot have both the movements simultaneously. That doesn't make sense. So how will you write that? So that how will you formulate the variable? How will you create the variable? So you can either have two variables, x1 L1 and x2 L2, or you can have a single variable xij and x where I is the from location and j is the two locations. So in that case, we'll have two variables xl1, l2 and xl2, l1. So which formulation? Okay, which formulation is more scalable, or which formulation is better?
So the first one, when we say x1, l1, then what does that mean? The number of
How many
numbers-
people are moving from L1? Yeah, I mean, it could be two also, but let's assume that it could be just from 25 people. Or is there any risk? Okay. And all of you know what is the meaning of the word scalable?
So if you have more than two locations, then first information doesn't
Yes.
information about where the person is going.
Right. So if you have more than, so today you have two locations, tomorrow if you have three locations, then you cannot first formulation is not sustainable. And apart from that, but let's say that we know that the factory will never have more than two locations. In that case, which is better?
That is same way.
Okay. And how will you ensure that if X1, L1 is, I mean, only one of them is positive, we will not have both of them positive? Or will it be ensured? I mean, let's say one of your objectives is, let's say that these movements come with a cost because people have to move from one factory to another factory, so there's a certain cost associated with that. So let's say you are minimizing that cost. So do I need to separately write a constraint to minimize the to ensure that we do not have constraint for that, or it will be taken care of by the solver?
We can move simultaneously from one location.
So we need to write a constraint. Others?
Objective is to minimize that cost. The model should automatically take care of it.
What if you have other objectives apart from minimizing cost? No, your answer can still be the same, but I'm asking what happens.
Depends on the objective. I mean,
You don't know what are the other, let's say there's 5 other or 10 other objectives apart from minimizing cost.
then still the objective should be of the kind of maximizing profit or something.
Minimizing cost.
Minimizing cost, maximizing profits.
Will it happen automatically?
I mean, it makes sense to migrate from one factory to another because one will have supply more than the other.
No, yeah, but do I need to write a constraint or no? Yeah, so I think we were discussing this earlier in one of the, we had this formulation about around overtime, non-overtime, I think we were discussing. So if you have only one objective, that is minimizing that transfer cost, transportation cost, then it will happen automatically. You don't need to bother about separately writing a constraint. But if you have 10, if you have other objectives apart from that objective, then it might be that due to some reason it prefers to transfer both ways because of the other objectives. So that time it is not guaranteed that that constraint is taken care of automatically. So in that case, you need to write a constraint explicitly to ensure that two-way movement doesn't happen. And what what will the constraint be? If you want to write a constraint that you don't have x1 and x2 greater than 0 simultaneously. Hmm?
So,
Hmm.
one question. So, suppose we got read this constraint and model is giving you that one movement should happen. Then isn't it the better option? Because if you add more constraint, then it will be less optimal than the previous.
No, but again, you don't. I mean, both way movement doesn't make sense, right? Why will you? So
but you always think that it's the better option.
No, but sometimes you have to specifically tell what are the rules which are practical. Unless if you don't tell the model what are the rules, it will not know by itself what are the rules. You have to tell them what is practical. It does not know what is practical and what is not. So yeah, as you said, if you add, so obviously it gives that solution because it finds it to be more optimal based on the objective set defined objective function. So if you add a constraint, that objective function value will deteriorate, obviously, but that is fine. So we want to go with a practical and less optimal solution than an impractical but more optimal solution.
So in that case, so the thing is कि one of them should be zero always.
Yes, one of them should be,
So
one of
then,
them should
and then
be, or both can be zero.
So then the product of these two should be zero. That is.
Then it will be non-linear.
Some should be less than equal to.
Some of them, but they are integer variables or
Then
continuous
we
variables.
can define because there is a movement.
You can define a binary variable which will indicate whether there is movement or not, and then let's say k1. Yeah, like x1 you convert to k1 and x2 can k2 and k1 plus k2 less than k2. So you want to stop here or continue? Or then we can meet after at 1:15. I wanted to give you guys sufficient time for lunch. So 1:15 will continue some other formulations, small formulations like this, and then we'll go to the next assignment. So next class will have, I mean, after next week, the next class will have is next Saturday, then 22nd on online.